We are still on redox reactions. So on the past video, if you didn't look at it, just check out on our channel. We have a playlist called General Chemistry. You'll find most of the stuff. We did talk about redox reaction, of which we call them reductions, and oxidation reaction, transfer of charge, losing and gaining. But today we are specifically going to look at balancing, or balancing equations, obviously redox. Okay, so I'm going to right here outline some very few steps that you need to comply with when you're balancing your redox reactions. I'm also going to do some 1 or 2 examples that are going to show you how this thing really works. So first of all, you need to divide your equations, as I did on the past video, into 2 halves. I'm tempted to just write half like this. Yeah, divide your equation into 2 halves. You know, it's your red and your ox equation, right? Redox and reduction and oxidation. And second step, you'll have to balance my spelling, balance your atoms, but not hydrogen and oxygen. Note this, not oxygen and hydrogen. Balance everything beside hydrogen and oxygen. And the third step is going to be, now you have to balance that oxygen you missed. You balance it by adding what? By adding water. Okay, and the fourth step is going to be, now balance your H by adding H pluses. Okay, and the fifth is going to be balance the net charge. You'll see it sound confusing if I'm just writing these notes, but I want you to have them, screenshot them, make a reference to them when we're doing the activities, because knowing them like this, it's really hard, but once you do it, you just get yourself used to it. Balance the net charge, and that is supposed to be a charge, by adding electrons where they are needed. And what else? And I just balance it, and number 7, what did I, it's 1 2 3 4 5 6. Okay, now make electrons transfer and gain equal. Equate, let me just say equate your electron in a redox and red and ox reactions. Just you're trying to make sure that the electrons gained by the other electron, the other atom, are the same as the one that lost from the other. Like, you can't be transferring and the other one get that different like that one. So you'll see it on the activity again. Let's put it number 7, and now you have to cancel anything that is the same. Okay, normally it is water. I'm not saying water will be the same, but normally it is water. Okay, this is the steps that you need to take if you're balancing the equation in an acidic solution. So for now, I don't want to confuse you a lot. Let's just work with this. So I'm just going to do some activity, and I'll be referring to these notes, and also you should just screenshot them, refer to these notes as much as I'm doing problems. Our equation that we'll be working with, trying to understand the step that I just showed you above, it's going to be this one. This is a 2 here, there's a 7 here, and minus plus Fe ion, and to give your Cr2, there's a 3 here, plus Fe3 here. So you know what I said, first step, you always make the half equation, right? Half equation. So let's look at this one. I'm doing the half, so I'm going to do an equation for this and this, and do equation for this and that. So that's why we call them first you do the half equations. That is a very first and very important step to easy up your work. So I just did my first equation, half equation, okay. So, and then let me just another one. So far I'm not speaking anything because I'm not doing anything exactly. I'm just copying what I see here, writing it here, just dividing it into 2. Okay, so let's look at here. We had 2 here, oxidation number was 2, and now it is 3. So the oxidation number increased. If the oxidation number increased, we said on the past video that thing is what? It's oxidized. So this one is an oxidation reaction. So without doing the math and everything, this is more than obvious. This is a reduction reaction again. So both of them, they make up what? A redox. Okay, so this is our very first and very important step. Don't worry about exactly if you don't worry if how many electrons were transferred or whatsoever. You just divide them into 2 and look at, if one can tell you if it's oxidized or reduced or reduced, you can just look at the other one. That one will be obvious, like they are complementary. And step 2 was like balance everything, but not hydrogen and oxygen. Balance everything beside these 2. Okay, so let me just write those things again. I won't write them again, I'm too lazy. I'm just going to come here and steal them. So now let's try to balance this. We have 2 chromiums here. I'll just make 2 here. And oxygen, they said you shouldn't worry about oxygen. Ion, they're the same both sides. So we just satisfied the first, the second step. If you feel like you're not following, just don't mind just scrolling back on the beginning of the video on the steps here. Screenshot this and use it as your reference. So you could just pause the video here, scribe this down, so that you'll use it for your reference when you're practicing. And as soon as you get used to it, you won't even need those notes. So you can use them now. So now step number 3 will be balancing the O's. So if you're balancing oxygen, you'll be just adding your waters. We agreed on this on the notes again. So this one doesn't have any O's, so we just out. We'll be looking at this one. This one has like 7 oxygen. To make it have 7 oxygen this side, we'll obviously have to do what? We'll have to add 7 waters. I don't know if that is allowed in the English literature, but 7 waters. We're going to add 7 waters, and now we have 7 O's and 7 O's both sides. So the next step, I don't know if I've just lost numbers. The next step will be obviously have to balance the hydrogens now. So we're just going to look here which one needs hydrogen. Okay, so this side we just added like these waters and they came with like and gave us 14 hydrogens. And that means we need to balance here by adding 14. Why can't I write it? Now still on the ion, there's nothing that we need to do there. So we have balance, we have we have O balance, and we also have hydrogen balance. By now you should guess what we have not balanced, and that is going to be obviously our next step. So if you made it here to this video and you've been following, congratulations, you're just 90% done. So the next step now will be balancing. We have this balance, we have this balance. The only thing, we have to balance the electrons. So this is our step now. We have to balance the electrons. So we're just going to do some small math here, and we have oxidation number of 2 here, of 3, to make this one 2 like this one. Remember, we can only add electrons. Okay, so to make this one balance again, we'll have to just do what you just said it. You have to add 1 electron this side. And now if you can check here, we have our we have our sum as 2, and we have our sum here as 2, so we have balanced the electrons. Let's look at from the chromium part. Okay, here let's do the math. This 14, okay, give us 14 plus, and this one chromium giving us what, 2 minus, and look from this side, this one will give us what, oh, there are 2, so 2 times 3 is going to give us 6 plus, and water is neutral, so 0 here. Okay, so let's work our math here, and this is going to give us 12, and this side 12 plus, and this side we have what, 6 plus. So to make this thing the same, we'll have to just subtract 6 here. To subtract 6 is just simply adding 6 electrons, right? So now if I look this side, I'll have 6, and if I look this side, I'll have 6. So I have solved it again. So just by adding what? By adding 6 electrons on this side. So let me just erase all this mess that I made trying to show you. So we're just going to take this electron and put it here, 6 electrons. So it is added. It is added. I'll just fix this on the next step. So I've written both of my equations like this. So remember, there's a step that we did mention on the notes, that the electrons gained here should be the same electron lost here. So here, this one had now we have 6 electrons here, and here this one we have like 1 electron. So to balance this is simply we're just going to multiply. Okay, to make things universal for every problem, we're just going to multiply here by 6. 6 is from this, and here we're going to multiply everything by this 1 here, multiply by 1. So just wasted your time. I need to multiply by 1, but the thing is, you have to keep that habit, because you're always going to multiply by these 2 numbers, or coefficient of the electrons. Okay, so if I do that now, I'll have everything having a 6. So let me just put those 6 here. It's going to be a 6 here. It's going to be a 6. There was an F. It's going to be a 6 here, and here we'll have everything having a 1. So 1 is going to be all over, and doesn't change anything. Okay, so this is where we are. So now it's that part of our way where we have to find everything that is the same. We said there's a step where you have to cancel everything that is the same, like this one is the same as this one. So we just needed to, I'll just erase it off. We just don't need it, right? And I'll cancel all of this, and this is it. So I can now write all my equations. I'm taking everything from the right and taking everything from the left. Let's start it from the right. We'll have 14 protons plus 6 Fe plus chromium 207. We have written this, and written this. So everything from the left is done. Let's look here. Here we'll have 2 chromium plus 7 waters, and plus 6 Fe 3 plus. So this is you remember at first you divided these equations into 2. Initially they were just 1 equation, so I'm just bringing it back where it used to be, how it used to be. So congratulations, in your 15 minutes you have learned how to balance a redox reaction in an acidic environment. So what if now it was basic? So there's nothing that is going to change. You're going to follow the steps that we have followed till this far, but the only difference you're going to do, you don't want those hydrogen plus. Okay, you need your OH for base, right? So let me say, what if it's basic? Okay, so if it's basic, note this well. Okay, if it's basic, now you have to get rid of this. Remember, we added this on some of the steps. Now we're taking them away. How do we take them away? We are going to add hydronium, right? But remember, because we have our equation all balanced now, if we do this on this side to keep it balanced, we have to do it from the other side. So let me just do it. It's basic now, so I'm just going to take the, so if it's basic, I'm just going to add my, I'm out of space, I'm out of screen, so I'm just going to add those OH minus. So if I do it this side, I have to do it the other side, just to make sure that to make sure that the equation is kept balanced. So just because we're trying to cancel these 14 protons, I'll have to add these 14 of them and add 14 of these. So if you notice, these, they just form water again. We have water again in our equation, so we're going to have 14 waters here, adding with 6Fe plus chromium 7 2 plus giving 2 chromium. I'm just copying everything. Now I don't know why I'm copying like this, because I just copied and pasted. So yeah, I just did it anyway. Plus 6Fe3 plus 14 OH. Okay, did I copy? Well, if I did any mistake, don't mind just to show me that you did a mistake there on the comment section. But I make sure that you get quality content in terms of the theory and science behind it. I might make a mistake, I'm a human. So let's just get to business now. So if you can notice here, we have 14 waters, and this side we have 7 waters. So these 7 waters are going to cancel other 7 waters here, and I'm going to have what? I'm going to remain with some 7 waters again here. So there will be 7 waters remaining here, and this hydronium will remain like this. So now this is our balanced equation in a basic in a basic solution. So if you could notice, you can see these confirming that it is really basic. You can see these, and if you can go up, because we started with the acidic one, we had these ones. So make sure that you go back here, screenshot these steps, and try to follow them as much as I tried to follow them. Screenshot here and try to do that problem following up if you can do it. And if you can't, just comment in the comment section why did you find it a problem, and also comment if there is other content that you want us to look at. All in all, please like and share, subscribe if you find the content informative and helpful, and also give us some video ideas of some things that you want us to work on or look at, maybe some math problem or any other thing. Thank you.